Multiplying and dividing radicals. So number one says, find the value of the following square root radical product. So we're going to start with multiplication. So products, remember, means multiplication. So multiplying radicals, you can just multiply what's underneath the radical, those radicands. You just multiply them, and then from there we'll have to simplify. But yeah, so we got the square root of 5 times the square root of 10. That's going to be square root 50. But we want to simplify this. We can't just leave it as square root 50. We want to simplify it as much as we can. So I think, okay, what's the biggest perfect square that goes in the square root of 50? That would be 25. So this could be, let me use that blue coloring I've been using. 25 times 2. And the square root of 25 is 5. So 5 root 2. Let me show you B. So I have the square root of 27 times the square root of 3. Well, 27 times 3 is 81. But this one's unique because I really wouldn't need to break this one up because the square root of 81 is a perfect square. The square root of 81 is just 9. So don't overthink some of them. And sometimes they're just going to simplify and be rational whole numbers or just, yeah. Let me do C. So now we have a couple coefficients in front of the radical. So what you're going to do is you're just going to multiply the 5 times the 3, and you're also going to multiply the 6 times the 12. We're just going to keep them separated. So 5 times 3 is 15. And the 6 times 12, those are what are under the radical. So 6 times 12 is 72. And now we go to simplify. So I can break up the 72. I'm going to rewrite my 15. Break up the 72. 72, we could go 36 times 2. Square root of 36 is 6. So this will be 15 times 6. Root 2. 15 times 6, I believe that is 90. So this is going to be 90 root 2. Let me do maybe one more of these. So letter F, I'm going to do the 2 times the 4, which is 8. The 12 times the 3, which is 36. And this problem is a little more similar to B, to where don't think about breaking up 36. You know what the square root of 36 is. The square root of 36 is 6. So this is just 6, and 8 times 6 is 48. And this is no different with cube root radicals. It's the same thing. You're going to multiply. So I'm going to do A and D. So 12 times 2 is 24. And now we can break this up. Cube root of 24 is not a whole number, so I'm going to break it up. Break it up into 2 separate cube roots. I think I can use 8 times 3. The cube root of 8 is 2. So 2 cube root 3 would be the simplified answer. D. We're going to do the 7 times the 3, which is 21. The 2 times the 4 is 8. So I have 21 cube root 8. The cube root of 8 is 2. So I can just do 21 times 2, which is 42. That one I didn't have to break up the cube root of 8 because it's a perfect cube. The cube root of 8 is 2. So it simplifies to a whole number on that one. So sometimes that's going to happen. So I'll let you do the rest of the products on this page. I'm going to move down. I'm going to do some quotients. Remember, the word quotient means division. So number 3 says, find the value of the following square root radical quotients. So A is square root 40 divided by square root 2. So similar to multiplying, when you had multiplied roots, you just multiply the numbers inside the root. And with division, it's the same thing. We're just going to divide the numbers inside the root. So 40 divided by 2 is 20. So now we have the square root 20. And we can simplify it. So we're going to break it up because square root 20 is not a perfect square. So this can go 4 and 5. The square root of 4 is 2. So 2 root 5. B is kind of unique because the numerator is smaller than the denominator. So we're going to have to use some simplifying. Like if you did 3 divided by 75, that's going to be a decimal. 3 divided by 75, I got 0.04. And we're not really going to work it that way. That's not the right approach that we should do with B. So what you can do in division, you can simplify these sort of like fractions. So if I have the square root of 3 divided by the square root of 75, and I think of the fraction 3 over 75, I can simplify that fraction. So 3 and 75 are both divisible by 3. So I'm just going to simplify this quotient first. So I'll show what I'm doing. I'm going to divide by 3 because they're both divisible by 3. So I'm just simplifying this to start. 3 divided by 3 is 1. 75 divided by 3 is 25. So that's kind of a strategic step that we're going to do with some of these radicals when they don't divide nicely. Sometimes you can simplify them. And now, hopefully this jumps out at you and say, oh, okay, I know the answer now because these are both perfect squares. The square root of 1 is just 1. The square root of 25 is just 5. So the simplified answer, the evaluating this, is just 1/5. Let me show another one just like that. Let me do F. So F is a tough one. We got 5 root 12 divided by 4 root 27. Again, 12 divided by 27, you can't just straight up divide those. You get 0.4 repeating, and that's just going to make it more complicated. So what we can do, though, is simplify 12 over 27. And similar to the earlier one we did, 12 and 27, they're both divisible by 3. So we can kind of simplify this fraction. So I'm going to divide those radicals by 3. So I'm going to have 5 root 12 divided by 3 is 4. And 27 divided by 3 is 9. And this one's kind of like the other one because we know what the square root of 4 is and we know what the square root of 9 is. The square root of 4 is 2. And the square root of 9 is 3. 5 times 2 is 10. That's going to be on the numerator. 4 times 3 is 12. That's on the denominator. So 10/12. That's the answer. But since it's 10/12, why don't we simplify that fraction? 10/12. They're both even numbers, so I know they're divisible by 2. So let's divide those by 2. We can go 5/6 with this as a more simplified answer. Okay, hopefully those 3 were a good amount. So let me show you a couple of cube root ones. I'm going to do A and B on this. So for A, I have cube root 3 over cube root 81. And I guess it's kind of just been coincidence that these are both divisible by 3. 3 divided by 81. Again, you can't do that. You're going to get a crazy decimal. So let's simplify these. And again, these are both coincidentally divisible by 3. So this is going to be cube root 1. And 81 divided by 3 is 27. And now this simplifies quite nice because the cube root of 1 is just 1. And the cube root of 27 is 3. So 1/3. B is a little more typical. I got the cube root of 32 divided by the cube root of 4. And these I can just straight up divide. 32 divided by 4 is 8. So this is going to turn to the cube root of 8. And this simplifies nicely because the cube root of 8 is just 2. So these you kind of have to play around a little bit with. Do some simplifying when you can and get the most simplified answer you can possibly get. Okay, I'll let you do all the rest.